So in this video, we are going to talk about two statistical machine learning problems. Problem one is a regression problem because our output space is continuous. And on this regression problem, we are trying to establish the relationship between variables x and y. From the scatter plot, we can actually see that there is a nonlinear relationship between the two variables, and that calls for a polynomial function space. I also suggested the loss function, which is the L2 loss, because it penalizes large differences between predictions and the true values. Okay. Yeah. I also determined the optimal degree since we're doing polynomial regression, and this was achieved through the V-fold cross validation. And from the findings, that degree 10 was the optimal degree indicated on this plot by the red line, as you can see it here. This is a comparison of the regression models considering degrees 3, 5, and 10. Also computed the empirical risks and the cross-validation error and plotted the cross-validation error, empirical risk versus the polynomial degree, which is 10. And from the plot, we can actually see that at degree 10, the empirical risk is lower than the cross-validation error for degrees 1 to 9, and that indicates that the model is performing well on the training data. But that doesn't necessarily mean it is going to perform well on the data it has not seen. This was the plotting of the models, a linear model, the optimal model, and the overly complex model. So from the box plots, from the test errors, we are able to conclude that the optimal model is outstanding of all the models since it achieves the lowest test error and that makes it stand out of all the models. I also ran the analysis of variance to make a conclusion on the three models, the optimal, the linear, and the overly complex. And the conclusion was that based on the p-value, which is smaller than the critical value, we have a strong evidence against the null hypothesis, confirming that at least one of the model's mean error is significantly different from the others. So that was it for exercise 1 or the problem 1, the regression problem. And our second problem was the classification problem because linear it involves binary classifiers. This is the distribution of the response. Our response was type, including non-spam and spam. From the distribution, we can actually see that there are more instances of non-spam compared to spam. I also used the whole data for training and testing and we built the ROC curves. From the ROC curves on this plot, we can actually see that the LDA model and FLD model are nearly overlapping, confirming their similarity in performance. But the LDA model comes out outstanding from all the models, able to compute the mean errors and the standard deviation errors. And from this, we can see that the LDA model and the FLD model achieve the smallest errors, and that implies that they are the best candidates for this classification task. Similarly, from the box plot, we can make a conclusion on the LDA and FLD models. Thank you all. That was it for the two problems of statistical machine learning.